Hey guys, so today we're going to talk about simplifying radicals, and in order to do that we need to start by talking about perfect squares. So a number is a perfect square if it's multiplied by itself. Alright, so the first 12 perfect squares that we want to look at are just the numbers 1 through 12. So if you know your multiplication tables really well, then you'll know these really quickly. So 1 times 1 is 1, 2 times 2 is 4, 9, 16, 25, 36, 49, 8 times 8, 64, 81, 100, 11 times 11 is 121, and 12 times 12 is 144. So those are your perfect squares. These numbers are considered perfect squares because these numbers came from a number times itself. All right, a variable is a perfect square if it has an 2 as an exponent. All right, so looking at variables with perfect squares, so x times x is going to be x squared. And then x squared times x squared is x squared squared. And then this one would be x cubed squared. And this one is x to the 4th squared. And you can see because it's times itself, that makes it squared. All right, so talking about square roots, we're talking about perfect squares so that we can talk about square roots. So taking the square root of a number is the inverse of something squared. All right, for example, 3 squared equals 9. That means the square root of 9 equals 3. The symbol square root tells you to undo the squared term or to take the square root. All right, there's different parts of a radical. An expression that contains a square root is a radical. And it can have 3 parts. So the index, you can see the index, that's a little number here. If it's a square root, it may have a 2 and it may not have a 2. So for a square root, you may see just this, or they may put the index here. For higher radicals like cube root, 4th root, they will always have an index. So that's why we're talking about the different parts right now. But just like if you have a variable and there's no number in front of it, it's assumed to be a 1. When you have a square root, if there's no index, it's assumed to be a square. All right, so the index is the little number, okay? It's the little number in the root. The radicand is the number under the root, and the coefficient is the number in front of the radical, okay? So there's spaces there for you to kind of put in your definitions, so you should go ahead and do that. Make sure you know the index is the little number in the root, the radicand is the number under the root, and the coefficient is the number in front of the root. All right, if we want to simplify the following radical expressions. All right, so the square root of 100 equals 10 squared. All right, so if we have square root of 10 squared, all I did was rewrite 100 as its perfect square, and then the square root cancels the squared term, so it equals just 10. So this one equals 5 squared, and 5 squared, the square root cancels the squared term and leaves just 5. Now the square root of 141, if you look at the 141, okay, 141 is not divisible by 2 because it's not even. It's not divisible by 3. Oh, it is divisible by 3. 3 and 47. So 3 times 47, but 47 is not divisible by 3, or 4, or 5, or 6, or 7, or 8, or 9. So 47, I believe, is a prime number, so this number is not going to break down any further, so you're just going to leave that as the square root of 141. All right, x squared, the square root of x squared is just x. And then x to the 4th, remember this index is assumed to be 2, so you can rewrite that as x squared squared. So the square root cancels the outside square, and it's just x squared. All right, now, again, if you want to rewrite these as perfect squares, you can say the square root of 2 squared x squared, and that means the square root cancels all the squared terms and leaves 2x. Same thing with this one. 81 can be rewritten as 9 squared. X to the 8th is the same as x to the 4th squared, and then y squared. And again, if we take out all the squares, the square root will cancel all of those. So we're going to have 9, x to the 4th, y to the 1st. And if you put a 1 there, it's fine. If you don't put a 1 there, it means the same thing. It's assumed to be a 1 as an exponent if there's no number there. Now, square root of 36, that is the same thing as 6 squared. And then a to the 6th is a to the 3rd squared. Remember, property of exponents. You have a power to a power, you add, so 3 times 2 is 6, so all we did was rewrite that. And then b squared squared. So I'm going to take off all my squared terms. I'm going to be left with 6a cubed b squared. All right, moving down. All right, when dealing with exponents, you always want to look for the perfect squares to get the exponent of the roots. So for here, you want to put, always look for perfect squares. If your radical, or if your radicand has more than one factor, simplify each factor or term. Sorry, I don't do a very good job writing on my computer here. All right, so you're going to simplify each factor or term. That means if you're looking for perfect squares, look for a perfect square in each part of the radical, not just the number. You're always going to look at both the numbers and the variables. All right, non-perfect squares. So we want to break down or simplify non-perfect squares. And the first one we're going to look at is the square root of 24. So since 24 is not a perfect square, then it has to be rewritten as a perfect square times something else. All right, to simplify this radical, 24 needs to be rewritten as a perfect square times something. All right, I'm going to give you a second to write that down. To simplify this radical, 24 needs to be rewritten as a perfect square times another number, or times something. However, one of the factors must be a perfect square. All right, so perfect square. All right, so what is the highest factor of 24 that is also a perfect square? Well, if you look at 24, you know that 2 goes into 24, 3 goes into 24, 4 goes into 24, 6 goes into 24, and 8 goes into 24. But when you're talking about perfect squares, 4 is your highest perfect square that goes into 24. Therefore, 4 times 6 is what you're rewriting 24 as. So 24 is 4 times 6, and 4 is the same as 2 squared. 6 is not a perfect square, so it's just going to be 6. So the square root of 2 squared is going to be 2 times the square root of 6. All right, if you ever need to pause the video to get these, go ahead and do that. I'm going to move on, just trying to get in what I can get in before the video ends. All right, to simplify square root of 32, we're going to do the same thing. Look at the highest number that goes into 32. So if you think 4 goes into 32, but 4 times 8, 8 is 4 times 2. So 4 times 4 would be your largest perfect square. So you can think of 16 is your largest perfect square that goes into 32. So 16 times 2. And again, the better you know your multiplication tables, the easier this is going to be. Because when you're talking about what factors and what numbers, essentially you're just talking about multiplication. So 16 times 2 is 32. 16 is the same as 4 squared. And then 4 squared, the square root of 4 squared. I guess I'm supposed to put just 16 here. And then this would be 2. And the square root of 4 squared is 4 square roots of 2. So the square root of 32 is equal to 4 square roots of 2. Those two are equivalent, okay? This one is just a simplified version. When it asks us to simplify, that's what we're doing, is rewriting it in a simplified term. All right, let's look at the next example, square root of 54. So 54 has a perfect square of 9 that goes in it. Okay, 9 times 6 is 54. And to simplify that, we would have square root of 54 equals square root of 9 times square root of 6. And we can write that as square root of 3 squared times square root of 6. And that becomes 3 square roots of 6. All right, I think I'm going to stop this video and then we'll pick back up for the rest of them on the next video. So if you have any questions, let me know.